Screen is visible today. Okay, today we are discussing about the enthalpy. For definition of enthalpy, let us consider a piston or a cylinder. Inside that one, piston will be there. Piston. Above that one, a weight is placed. Because of heating, the gas will expand. The above weight over the piston act as a constant pressure. Here, a constant pressure is maintained. But because of the heating at the bottom, the expansion will take place. Increase in volume, but weight remains constant. We call it a constant pressure. Consider a mass of a gas in a cylinder at a constant pressure P, while when heat is added, this gas undergoes to a state 2. Pressure remain constant here. Here the pressure remains constant. That means it dead continuously, but volume is increased. From the first law, we know that delta Q is equal to delta U plus delta W. Now we know that delta W we can write as integration of 1 to 2 P dV. We arrived this one in the chapter 1. This formula, work done formula, integration 1 to 2 P into dV. Here normally used to do W is equal to integration V1 V2 P into dV. The similar I have written in terms of 1 because we have moved in 1 and 2. Or if you want to write in this fashion also, you can write it. Okay. Since pressure is constant, delta W can be written as, for constant pressure, we know that the formula P is equal to V2 minus V1. For constant pressure, the formula is P is equal to V2 minus V1. Chapter 1, chapter 2, module 1, chapter 2. Here, if you multiply further, you can write P1 V1 V2, P2 V2 minus 1 V1, because in the constant pressure P1 is equal to P2. This is the diagram for constant pressure. Here the volume will changes, V1 and V2, P1 and P2 becomes equal. This is the constant pressure diagram through which we have done formula in the work done, that is P is equal to P2 minus P1. Chapter 2. Similarly we are applying here. The work done, we got it. Let us consider this equation 1, equation 2, equation 1 and equation 2. Substitute equation 2 in 1. then it becomes delta Q is equal to delta U plus P2 V2 minus P1 V1 P1 V1 minus P1 V1. Internal energy can be written as delta W, we can write as U2 minus U1. Internal energy can be written as U2 minus U1 plus P2 V2 minus P1 V1. Let us rearrange it. Delta W is equal to U2 plus P2 V2. We are considering these two first. Next, close the bracket, minus I am considering this two term, minus U1 plus P1 V1. Delta U can be written as U2 minus U1, change in internal energy. We can find out only the change in internal energy. Absolute energy we can't find it. We can find the change in energy, that means volume 1 and volume 2 we can find. Now we have wrote this one. Now based on this one we are going to find out the enthalpy. That means thus during this process the quantity U plus PV undergoes a change between the initial state and final state. Since all these quantities are thermodynamic properties. Their combination must also have same characteristic. Therefore, a new extensive property namely enthalpy can be defined as
Sir, the screen is not visible, sir.
now
Can't the screen is visible. Now visible, sir.
now can be defined by H is equal to U PV. That means if you want to define the enthalpy is nothing but change in internal energy plus product of pressure and volume, we call as an enthalpy. How we arrived this one? By using the first law of thermodynamics applied at a constant pressure. We have substituted the work done. The formula at constant pressure work done is P is equal to V2 minus V1, which is furtherly simplified as P2 V2 minus P1 V1. This is the diagram for constant pressure. Now in place of delta W, substitute this value. We have substituted. Now delta U is nothing but change in internal energy. It can be obtained U2 minus U1. We can only through the change in internal energy. u2 minus u1. It remains same. Now rearranging it, u2 plus p2 v2, we have rearranged it. This term u2 plus p2 v2 we call as an enthalpy. The new term arrived we call as a enthalpy. Enthalpy is nothing but it is a internal energy plus product of pressure and volume. We call as an enthalpy. Enthalpy we call as an enthalpy. Or per unit mass, if you divide by per unit mass, if you divide by a mass, then it has to be written in terms of small. H is equal to u plus small pv, we have to write it. If you divide by mass, we have to write in terms of small letters, small letter, where H is nothing but total enthalpy in terms of kilojoule. Small h we call as a specific enthalpy. If the specific enthalpy indicate, that means we have divided by mass. That means kilojoule per kg. The unit will be kilojoule per kg. Specific enthalpy is nothing but kilojoule per kg. Further, we need to define specific heat. For the enthalpy, this is the explanation is enough. Up to here you have to write it. For specific enthalpy, specific heat is defined as the amount of heat required to rise the temperature. Amount of heat is required to rise the temperature. Specific heat is defined as the amount of heat required to rise the temperature of unit mass of substance by 1 degree, for 1 degree. That means it is the amount of heat required to rise the temperature of a unit mass, a small mass there. If you want to heat it by 1 degree, then we call as a specific heat. Now there is a formula for specific heat. C is equal to delta Q divided by dt into delta M. This is the formula for specific heat. Now this is a general formula for specific heat. If you go for in terms of mass is concerned, you have to write delta Q divided by dt. This is a general formula for finding the specific heat. You have to remember this formula directly. For gases, we have two kinds of specific heat. Namely Cp, specific heat at constant pressure, specific heat at constant pressure, we have to write delta Q divided by dt in terms of pressure. specific volume specific volume specific heat at constant volume specific heat at constant volume, we have to write delta Q divided by dt. We have to write V here. We have to write V. This is about the specific heat. Now we are discussing about the constant volume. We are discussing about this one now, this part. Let us discuss. ಈಗ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ ಏನಿದೆ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಇಂದ ಇಲ್ಲಿ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ. Now at constant pressure, first I will consider the constant volume from first law. We know that delta Q is equal to delta U plus delta W here delta W delta U plus delta W for constant volume we can write as P is equal to dV. Work done P is equal to dV for constant volume. But for constant volume, what is the work done? Anyone? What is the constant volume for work done? ಏನಿರುತ್ತೆ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಫಾರ್ ವರ್ಕ್ ಡನ್ ಅದು ಹೇಳ್ಬೋದಾ? For constant volume, the work done. This is the diagram for the volume, PV diagram. This is the line. This is the pressure, P1, P2, V1, V2. Then what happens?
Zero irutte.
Zero irutte. But before deriving, the delta W will be written in terms of P is equal to dV. We will write in terms of P is equal to dV. For constant volume, the work done will be zero. Otherwise, you can write directly zero here, no problem. That means we can write P dV is equal to 0 or delta W is equal to, you can write 0 directly, because at constant volume the work done will be 0. It can be written as delta Q is equal to delta U. Now if you divide by mass, it can be written as delta Q equal to delta U. Delta Q divided by delta Q. Delta Q divided by delta U. Now see here. Now substitute. Let us consider equation 2. Substitute third equation in 2. Then it becomes what? C is equal to, in place of delta Q, I have to substitute delta U dt. This is for constant volume. We have arrived this formula. Delta U is equal to, in terms of specific heat, delta Q delta H okay. In terms of delta Q, specific volume at heat at constant volume. Okay, no problem. It will remain same. Now C is equal to, in terms of volume, we have to write delta U is equal to dt to V. ಲೆಟ್ಸ್ ಗೋ ಫಾರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್. ನಿಮ್ಗೆ ಹೇಳ್ತೀನಿ, ಇದು ಕ್ಲಾರಿಟಿ ಕೊಡ್ತೀನಿ ನಿಮಗೆ. ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್, for constant pressure we know that enthalpy H is equal to U plus PV. Already we arrived at this. If you go for differentiating, it becomes dH plus du. If you differentiate, this is nothing but product differentiation. Product differentiation, that means the first should be retained as it is. We have to differentiate dV. In second case, we have to differentiate, we have to keep the velocity or volume as it is. We have to differentiate pressure dP. We call as a product rule. Product rule anta karitvi. We call as a product rule. Product rule. Let us consider AB. In order to apply the differentiation for AB, first we have to make A as it is. Next we have to differentiate B. We have to write dB. Next we have to keep B as it is. We have to differentiate dA. This we call as a product. We have to apply the product rule. After applying the product rule, see here, UV du or here du is nothing but delta U. One more time I will write dH is equal to delta U plus P into dV plus V into dP plus P into dV is nothing but Q, is nothing but delta Q, is nothing but delta Q, is nothing but delta Q. Here is nothing but delta Q. dH is equal to delta Q plus V into dP, V into dP. Now we are discussing about the constant pressure. Now write delta Q is nothing but delta U plus P into dV. Here P into dV, which is nothing but delta Q. I have written here delta Q. We know that the pressure remains constant, therefore V into dP is equal to 0. Further, dH is equal to delta Q. If you divide by mass, it becomes small dH into delta Q. Small dH into delta Q. Now substitute in this equation. In this equation I have to substitute. The first value has to substitute in this equation. Ali 2 anta ಹೇಳ್ಬಿಟ್ಟಿನ. Okay. Let us consider this is a 2, 3, 4. Substitute 4 equation in 3. Let us consider this as a substitute fifth equation in A. Substituting fifth equation 5 in A. Then it becomes Cp, because we are representing the constant pressure Cp. In place of delta Q I have to write dH divided by dTp. This is the formula for constant volume and this is the formula for constant pressure. Any doubt regarding this part? Doubt idre ಹೇಳ್ರಿ. ನಾ ಏನು ಮಾಡಿದೆ ಅಂದರೆ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನಾವು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ವಿ ಹ್ಯಾವ್ ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಹಿಯರ್ 3 and A. Any doubt regarding this part?
ಸರ್ ಇದು ಡೆರಿವೇಷನ್ ಮಾಡಕ್ಕೆ ಹೇಳ್ತಾರಾ ಇಲ್ಲ ಇದು ನಮ್ಮ ನಾಲೆಡ್ಜ್ ಇದೆ?
ಇದು ಜಸ್ಟ್ ಫಾರ್ಮುಲಾಸ್ ಬೇಕು ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ. ಇಲ್ಲಿ ನಿಮಗೆ ಇದು ಕೇಳಲ್ಲ. ನಿಮ್ಗೆ ಕೇಳೋದು ಏನಂದರೆ ಡಿಫೈನ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಅಂತ ಕೇಳ್ತಾನೆ. ನೀವು ಇಷ್ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಇದು ಮಾತ್ರ. ಇದು ಬರಲ್ಲ, ಈ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲಿ ಬರಲ್ಲ ನಿಮಗೆ ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡಿ. ಫಾರ್ಮುಲಾಸ್ ನಮಗೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕೆ ಬೇಕು. ಡೆಫಿನೇಷನ್ ಜಾಸ್ತಿ ಕೇಳ್ತಾನೆ.
ಓಕೆ.
ಹಾಂ, ನಿಮಗೆ ಯಾವುದು ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ ಅಂದರೆ
ಸೊ ಈ ಥರ ಡಿರೈವ್ ಮಾಡಿ
ಹೇಳಲ್ಲ. ಇಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು ನೀವು.
ಓಕೆ.
ಸ್ಪೆಸಿಫಿಕ್ ವಾಲ್ಯೂಮ್ ನಮಗೆ ಇದು ಫಾರ್ಮುಲಾಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ಗೋಸ್ಕರ ಬೇಕು. ಓಕೆನಾ? ಅಷ್ಟೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಇಲ್ಲ ಈ ಪಾರ್ಟ್ ಎಸ್ಪೆಷಲಿ. ದ ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಸಿ ಪಿ ಆ್ಯಂಡ್ ಸಿ ವಿ. relationship between CB and CV. ಹಾಂ, ಆದರೆ ಈ ಡೆರಿವೇಷನ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಇದು ಇಂಪಾರ್ಟೆಂಟ್. ಕಾಣ್ತಾ ಇದೆಯಾ? ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಮತ್ತು ಇದು ಇಂಪಾರ್ಟೆಂಟ್. ಪ್ರೂವ್ ದ್ಯಾಟ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಇಸ್ ಎ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಸಿಸ್ಟಮ್. ಇದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಈ ಎರಡು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಇಲ್ಲಿ ಡೆಫಿನೇಷನ್ ಮಾತ್ರ ಕೇಳ್ತಾನೆ. ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್, ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಡೆಫಿನೇಷನ್ಸ್. ನೆಕ್ಸ್ಟ್ ಇದು ಒಂದು ಕೇಳ್ತಾರೆ ನೋಡ್ರಿ, ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಸಿ ಪಿ ಮತ್ತು ಸಿ ವಿ ರಿಲೇಷನ್. ಯು ಹ್ಯಾವ್ ಟು ಡಿಫೈನ್ ದ ಸಿ ಪಿ ಮತ್ತು ಸಿ ವಿ ರಿಲೇಷನ್ಶಿಪ್. ವಿ ನೋ ದಟ್ ಎಂಥಾಲ್ಪಿ H is equal to U plus PV. Mass, it becomes small h, small u plus PV. Now PV can be written as MRT. Here PV can be written as MRT. H is equal to, for ideal gaseation, is equal to MRT. If you divide by mass, it becomes H is equal to U into small PV, where small PV can be written as RT. Small PV can be written as RT. Small PV can be written as RT because we are divided by mass. Therefore H equal to U plus RT. Differentiating the above equation, then it becomes dH equal to du plus R into dt. After differentiating, this becomes an equation. ಈ ಥರ ಬರುತ್ತೆ. dr is nothing but constant which has to be kept outside. Next, consider this equation 1. We know that CV can be written as du dt into P. P is nothing but constant pressure. ಇಲ್ಲಿ ಅರೈವ್ ಮಾಡಿದ್ದೀವಿ. CV can be written as delta U plus dt, or it can be written as delta U plus dt into P. ಇದು ಅರೈವ್ ಮಾಡಿದ್ದೀನಿ, ಆ ಇಕ್ವೇಷನ್ ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ. delta U, just cross multiply CV into dt. P get constant pressure. Consider this equation 2. Again, we know that Cp is equal to, what is Cp value? This is the Cp value, dH divided by dt, ಇಲ್ಲಿ ನಾವು ಪಿ ತಗೋಬಾರ್ದು, ಇಲ್ಲಿ ವಿ ತಗೋಬೇಕು ನಾನು, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಎ ವಾಲ್ಯೂಮ್. ಹಿಯರ್ ಇಟ್ ಇಸ್ ಎ ಪ್ರೆಷರ್ ಪಿ, ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ವಿ. ಇಲ್ಲಿ ವಿ ಬರಬೇಕು, ವಿ ಬರ್ದಿದ್ದೀನಿ. ಹಿಯರ್ ಐ ಹ್ಯಾವ್ ಟು ರೈಟ್ ಪಿ, ರಿಟರ್ನ್ ಪಿ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ dH is equal to Cp into dt. Equation 3. From equation 1, 2 and 3. Equation 1, 2 and 3 we can write. Here we need to substitute here.
Sir,
CP,
CP is equal to dh by dt ಇದೆಯಲ್ಲ dt ಆ ಕಡೆಗೆ ಹೋದ್ರೆ CP into dt is equal to dh is equal to CP into dt ಆಯ್ತು. ಅಲ್ಲಿ p ಇದೆಯಲ್ಲ ಅದೇನಾಯ್ತು? p ಬರೆದಿರಲ್ಲ
ಇಲ್ಲಿ ಪಿನಾ ಪಿ ನೋಟೇಷನ್ ಜಸ್ಟ್ ಇದು ನೋಟೇಷನ್ ಓನ್ಲಿ ಪಿ ಅಂದರೆ ಪ್ರೆಷರ್ ನೋಟೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಇದೆ ಅಂತ ಅಷ್ಟೇ, ಅದು ನೋಟೇಷನ್ ಮಾತ್ರ. ಅದು ನೋಟೇಷನ್ ಅಂದರೆ ನೋಟೇಷನ್ ಬರೆದಿದ್ದೀನಿ. ಪಿ ಅಂದರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಅಂತ, ವಿ ಅಂದರೆ ವಾಲ್ಯೂಮ್ ಅಂತ, ಅದಕ್ಕೆ ಸಂಬಂಧ ಇಲ್ಲ ಇದು ಫಾರ್ಮುಲಾ ಜೊತೆ.
ಸರಿ ಸರ್, ಓಕೆ.
ಇದು ಜಸ್ಟ್ ಯಾಕಂದರೆ ಕನ್ಫ್ಯೂಸ್ ಆಗಬಾರ್ದು ಅಂತ ವಿ ಅಂತ ಬರೆದಿದ್ವಿ. ಪಿ ಅಂತಂದರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಅಂತ, ವಿ ಅಂದರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಅಂತ. ಓಕೆನಾ?
ಓಕೆ ಸರ್.
ಇದು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ, ಏನೋ ಆ್ಯಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ, ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು ಜಸ್ಟ್ ನೋಟೇಷನ್. ಇದು ಪ್ರೆಷರ್ಗೆ ಹೇಳ್ತೀವಿ, ಇದು ವಾಲ್ಯೂಮಿಗೆ ಹೇಳ್ತೀವಿ ಅಂತ. ನೆಕ್ಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಇನ್ ದಿಸ್ ಇಕ್ವೇಷನ್ dH Cp into dt, du value, or you can write the formula ಈ ಥರ ಬರೆಯೋ dH is equal to delta U plus R dt. You can write it R dt. Now du can be written as Cv into dt plus R dt. Now divide by d, it becomes Cp is equal to Cv minus Cv plus R. Further it can be written as R is equal to Cp minus Cv. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ.